Okay, this is going to be a review for Unit 2. Unit 2 review. Okay. First one says find the function represents this sequence. So we have right here, you can see the different ones. If you want to make this into a table, it goes the other way, you can. So when I look at this, I can see that this has been multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. So I know that my multiplier is going to be a 3. So I know R equals 3. So when we do this, remember we can go that, AN is equal to A times R to the power of X. Okay? So we know this is going to be 3. And remember this is 0, and this is, we can say that is minus 0 right here. So we don't have a 0, so we can use this one, though. But to use that one, then we're going to go, it's going to be A1 times R to the, and I'm going to use N this time instead of X. It's going to be N minus 1, okay? So AN is equal to A1 times R to the N minus 1. So let's plug that in, and A1 is 4, R is 3, and this is going to be N minus 1. Okay, and that is how we can leave the answer just like that. Now, if that's not one of the answer choices, then we've got a different problem because you're going to have to take it back to 0. So to take this thing back to 0, if that's not one of the answer choices, and you can multiply this out and see, or the answer choices and see if it will give you, these answers. Just plug in a 1, plug in a 2, plug in a 3, and see if it's going to give you, 4, 12, and 36. For the answers. So you can also take this thing back to 0. So my 0 term, we'll squeeze it in right here. So this is going to be 12 divided by 3 is 4. 4 divided by 3 is 4 thirds. So you can write this as simply 4 thirds times 3 to the power of n. So you can do that. And if you wanted to get you 0 another way, and let me find my good graphing calculator here. You can just put this in on a table. Let's do that. Let's just make this on a table right here. So I'm going to go 4 parentheses 3 close parentheses raised to the power of X minus 1. And if I put that on a table, then you can see that I want to get these numbers there. There's 5 is 324. So we got it right if we do that. There's 3 is 108, and 3 is 36. And the next one's going to be 12, and the next one's going to be 4, and the next one's going to be 4 thirds, and 4 thirds is 1.333333 repeating. That is 4 thirds. So you can write it as 1.3333 repeating, or better yet, then just go 1.3 repeating to the 3 to the power of n. This is the best way. That's the way the answer is probably going to be on the test. It's either going to be that or it's going to be that. Okay, the first 5 terms, okay, second one, first 5 terms are here. So you can see, all I've got to do to find the common ratio is divide these things. So I'm going to go 20 divided by 4, 20 divided by 4, I get 5. I'm going to go 100 divided by the previous number, 20, is going to be 5. 500 divided by the previous number is 100. It's going to be 5. And then 2,500 divided by 500. So it's going to be 5. So that's one answer. What's the common ratio of the function? It's going to be 5. Write an explicit function to model the value of the nth term of the sequence such that f of 1 equals 4. So there's f of 1, okay? That is a1, or f of 1 is 4. Okay, so a1, so I could say this. I can say a1 equals 4. Or I can say f of 1 equals 4. So this one I'm going to be using like y's and x's and stuff on this one. On this one I'm going to be using n's and a1, a2, a3, and so forth on that one. So let's write an equation on this. So again, you can do it the same way we did this other one. It appears very similar. So we know the first term, and the first term is going to be 4. So we put in 4. My multiplier is 5. And if I put in a1, remember this has got to be n minus 1. So there's the answer. Just f of x. F of x equals that. And if you put in a 1, that should give you 4 for the answer. And 5 minus, let's just do that real quick in our head. 1 minus 1 is 0. 5 to the power of 0 is 1. 4 times 1 is 4. That gives us 4. Now, again, if that is not the answer, we're going to have to take this thing back one more space, because that is A1, there's A2, A3, A4, A5. Let's take it back to 0. So take it back to 0, then let's just 100 divided by 5 is 20, 20 divided by 5 is 4, 4 divided by 5 is 4/5. So we can also write that as y equals, and I hope I had that on the camera if y'all see it, okay? Let me just go back in case I didn't. This is just going to be, first term is 4, my multiplier is 5, and that's going to be n minus 1. If I use the first term, I got to use n minus 1. If I'm going to use the 0 term, which I just found to be 4/5, so there's my 0 term, multiplier is 5, then I'm just going to put n right there. And again, that may be x also. If it's y, actually if it's y, it's probably an x. If it's a n, it's probably going to be an n right here. Okay, let's move on. Now this is going to be just jumping around a whole lot. So, I might not have any more on this page, so let me just flip through here. Okay, I see one back here. Okay, a catfish farmer put catfish into his pond. They quickly began to multiply. The increase in number of catfish, C to the x, C of x, is A0, 3 to the t. So that means it's tripling every year, okay? That's what that means. Where t is the time in months the fish have been in the pond, and A0 is the number of fish you put in the pond. What is the rate of growth? Well, it's going to be 3. Now, another way you can put that is a 300%, okay? 3 is 300%. So I don't know if it's going to be a percentage or if it's just going to say 3, which is tripling the rate of growth. You can say that it is tripling, being multiplied by 3. If the pond contains 800 catfish in 4 months, how many catfish did the farmer initially have in place? Now, what I want to do on this is, I'll do it a couple ways. So probably the easiest way is just put it on a graph. So we got 0, which is the initial amount, which is what we're looking for. Okay. So initially place we want to be 0. We got 1, 2, 3, and let's see, we got 4 months. So we got 4 months is 810. So we know this thing is multiplying, going this way, or multiplying by 3. But if I'm going this way, I've got to divide by 3. So all I've got to do is come up here and just say 810 divided by 3. So 810 divided by 3 is going to be 270, goes here. 270 divided by 3 is going to be 90. 90 divided by 3 is going to be 30, and 30 divided by 3 is going to be a 10. Okay. So that gets us back to 10 right here, so that we can say how many initially have in the pond. It is going to be 10. You can go backwards and say, it's tripling. So if this is 10 triples to 30, 30 triples to 90, 90 triples to 270, 270 triples to 810. It's one way to do it. Another way to do it is we can go ahead and write an equation for it. So our equation is going to be AN is equal to, we know the 4th month, so we know A4 is 810. We know it's tripling, and this is going to be N minus 4. This is A4, this is N minus 4. So remember, these two numbers have to be the same. If this is A4, must be N minus 4. So I'm going to put that in my calculator, and you can see, then I'm going to make it a table, and you can see that we're going to get exactly the same thing. So let me clear this out. So it's going to be 810, parentheses 3, and you can do the same thing on your Desmos graphing calculator. Raise the power of N minus 4, and I'll make it into a table. And make a table, then you can see that, there's my, 4th is 810. There's the 3rd one. There's the 2nd one. There's that one. And you go all back to 0, and you can see we get 10. So either way you do it, you're going to get 10. Okay, next one. William starts a Facebook page for people who live near Gracenote Middle School to share news and photos. He signs up 52 family members and friends before going public. He uses the following function to estimate the number of followers after W weeks. What is the growth rate that William expects each week after launching the Facebook page? So the growth is right here, and that is 1 plus R. So we got to separate that, and it's going to be 1 plus 0.055, and then we need to change the 0.55 to a percentage. So I'm going to add a percent symbol and move my decimal over twice. So I'm going to get 5.5%. So this thing, growth rate, 5.5%. Okay, each week. How many users should William expect after the first 4 weeks? Now, I think on the test that I put this month, and I may have to go back and change that because I'm trying to think what month I gave that to you on this test. But anyway, we're going to go with a 30-day month, okay? A 30-day month. So if I'm going to go with a 30-day month, then we need to write it. Here's the equation. So on this right here, we're going to say it's going to be 30 days. Well, how many months, how many weeks is 30 days? So on this one, we're going to have to go y is equal to, this one was a tricky one, okay? So it's got to be 1.055 to the power of 30 over 7. So 30 days, 7 days in a week. So, if it was 7 days, it'd be 7 over 7, 14 days is going to be, that's 2 weeks. 28 days, 28 divided by 7 is going to be 4. Well, this is a little bit more than that. So we're going to write it just like that. So I'm going to just come up here and put this in. So it's going to be 52, parentheses, 1.055, close parentheses, raised to the power of, and all you got to do is just go 30 divided by 7. Don't make it difficult, okay? Y'all made it difficult on that last test. And when I do that, for my answer, I'm going to get about, I'm going to just round this off to the nearest whole number. So it's going to be about 65 people. About 65 people, okay? So if it's a 31-day month, and I'm going to have to go back and see, which one it was, because I want you to be able to get the answer correct. If there's 31 days of the month, then that just make that 31 divided by 7. So let me do that. If it were 31 divided by 7, then just go back and change that to a 1. And you can see that it would be, another day, and you're going to get 65.9, which would round to 66. So again, we're not going to put 65.9 because we're not going to put, users. We're going to put people. You can't have parts of a person. Okay, so that's number 13 on this test. Okay, let's look at this. Okay, assume that 20 squirrels are put in a closed wildlife ranch, and the squirrel population grows for the next 5 years, as shown in the table right here. Write a function represents this, so I would hope you can do this. You can see that it's going to be y is equal to the initial amount was 20, and this thing is every year it has been multiplied by 4, so 4 is a multiplier, and that's just going to be to the power of x. X is going to be years. So there is my equation. A second group of 20 squirrels of a different breed is placed on a different ranch. The population of squirrels triples each year. These are quadrupling, so the new ones are going to be tripling. So if they're tripling, there's going to be y is equal to, we started with 20, and they are going to triple each year. So there is going to be it. So let's look at this. So we got these two things. Let me just put them both right here so we can see them together. We got the first one is y is equal, this is the original one, is 24 to the x, and then on the new ranch, the second ranch, then it becomes 23 to the power of x. The coefficient will become 2. Now the coefficient, if you want to say that's the number, actually there is no coefficient because the coefficient is the number in front of x. So there is just a 1, and it's a 1. It's not going to change, okay, to anything. The function rule become linear? No, it's still tripling every year. This is quadrupling, still going to be exponential. The y-intercept of the graph will be different. Note both y-intercepts are going to be 20. It starts off at 20. The base of the exponent changes from a 4 to a 3. It changes from a 4 to a 3. Yep, so that's true. As the number of years increases, the graph of this model will be steeper than the original model. So look, this one is steeper than this one. Okay, so to find out which one is steeper, then you've got to look at the multiplier. Okay, so the multiplier here is 4, the multiplier here is 3. This is going up faster or at a steeper rate. So as the number of years increases, the graph of this model will be steeper than original? No. Okay, as the number of years increases, the graph of this model will be less steep. So the graph of this model, meaning this one right here, is less than the original model, which is this one up here. So make sure you get those straight in your head. So it's going to be F, and it's going to be D on this one. Okay, next one. Had the second group start with 40 squirrels instead of 20, which population will be bigger by year 3 and by how much? So started with 40, then it's going to be 40, and it's going to triple every year. And all we want to do is just put in a 3 right here after 3 years, and we can look at that. So if it started with 40, so we got 40, triples after 3 years. So when I do that, then I'm going to get 1,080. So this one is going to be 1,080. And the original population after year 3 is, up here, look, it's 1,280. So we got 1,280. So which one is bigger? The original population would be bigger by 200. Okay, by 200. Now, did it start bigger? Nope, it didn't start bigger. If you want to put these on a table, then you could, and you can compare them just side by side if you wanted to. So this is year 0 is going to be 40, and if we put in year 1, then we're up to 120, and year 2 is going to be 360, and year 3 is tripling again. It's going to be 1,080, and let's look at the other one, which would be year 1 was 20, so this one has more. Year 2, this one has 80, this one has 120, it has more, and then this one is going to, not passing it yet, because we got 3 is 320, okay, multiplied by 4, so this one is still bigger, but after, and I looked at that wrong, okay, or did I look at that wrong? Okay, no, I see what I did wrong right here on my table, so scratch this. I got this right, but I got my table wrong. So this is 0 is 20, and 1 is going to be up here at 80, and 2 is going to be 320. So at 2, this one's still bigger over here, okay? This one's still bigger over here. And then year 3, then this one is going to outperform it, and it'd be higher after, somewhere between year 2 and 3, it's going to surpass it. And there's one that's going to ask you when some of these surpass another graph that you got to know. Okay, let's look at this one. Okay, so Melinda has 2,500 followers on her Instagram. Her number is increasing by 11%. Write a function. It's also actually write a function. So she started with 2,250 initial amount, and it's growing by 11%. So that's going to be 1 plus 11%, which is going to give you 1.11. And that is going to be to the power of WX, whatever you want to put for the exponent there. So there is, and just match it up with whatever's in the, that you got there on the answer choices. Let's look at number 2. Number 2, this is an experiment. It just says find the average rate of change over the entire 10-minute experiment. So that means we got to get 2 numbers. We got 0, 10, and 10 minutes later, we're down to 10, 1. So we've got 0, and 10, and here we got 10 and 1. How much did that change? Well, it went up 10. How much did that change? Well, it went down 9. So that is going to be negative 9/10, which is going to be, you can write that as negative 9/10. So the answer is going to be, it's going to be A on this one right here. Okay, let's look at number 3. Number 3. So again, all I did, guys, is remember that it's going to be the change in Y over the change in X. Well, how much did the X change? It went up 10. How much did the Y change? It went down 9. So change in Y over the change in X, and that's all the equation that we're going to be using on this. Okay, let's go on. Okay, the number of half-lives, this is something that y'all have in science, and half-life is going to be the initial amount. So I'm just going to look at it. I don't forget about the answers. I'm just going to cover them up down here. And I want to say the A0 is 12,000. And it's a half-life, so the multiplier is 1/2, and that's going to be to the power of x. And then find out which one that is, and of course it's going to be C right here, and that's it. So that one's really simple. Okay, let's look at this one right here. Okay. The y-intercept is 4. The x-intercept is 1. The asymptote is approaching -2, so it's y equals a -2. The range of this is going to be from -2 up, so it's going to be y is greater than -2. It does not touch -2, so it's going to, don't put a line under it. It is greater than -2. And the domain, anytime it's just a plain old graph, the domain is going to be all real numbers. Okay, now we got positive and negative. Okay, so let's look at the negative values. F of x is negative, which means the y values are negative. All these y values are negative. Well, where is that on my graph? F of x is negative for all x values that are where x is greater than 1. So anything greater than 1 is negative. Anything less than 1, so if I put x is less than 1, then they're going to be, these over here are the ones that are less than 1, and that means that it's going to be positive y values. And then if we have x equals 1, that means that point right there, and that means at that point that y is 0. It's not positive, it's not negative. As x increases, which means we look at the right arrows, what that means. So as x increases, look at the right arrow. Y, or f of x, approaches but never reaches -2. Okay, next one. This graph shows an exponential function. Write an equation. Okay, so two things I need to write an equation on this. I need y is equal to, I need A0, and I need R. And that's all I need. I need those two things. So I know A0, I can get it off the graph. It's right there. So I know y is equal to 3. So now I just got to get my multiplier. To find my multiplier, all I need to do is I've got this point, and that's kind of hard to see on this one. Maybe it's not going to be that hard on the ones you have, but that is up to 7.5. So if I look at my table, then 0 is 3 and 1 is 7.5. So to find my multiplier, I'm simply going to take 7.5 and divide it by 3. And when I do that, I'm going to get 2.5. So multiplier is 2.5. Another way that may be written, 2.5. 2.5 is 5 halves. So it could be 5 halves, it could be 3, 5 halves to the x. So one of those two answers is how it's going to look. Okay, so it's all you got to do is just, all we're doing is we're finding the multiplier. So to find the multiplier, then, and if we're told it's exponential, it is exponential. So it shows an exponential graph. So that means that here and here, that it will always be the same. So just pick your 2 points. We've got 1. So either use point 1 something or 2 something, and you'll find you a lattice point preferably. This one is not a lattice point, so you just have to kind of look at it and say, hey, it goes halfway between there. It's 7.5. 7.5. And if you want to check it, you could put that in there and you could check it and just see if it looks like some of these other points are going to be right. So in other words, -1 looks like it's going to be 1.1 maybe, something like that. So let's try that and let's see if it does give us that. So I'm just going to come up here and I'm going to check it. So I'm going to put in 3 parentheses 2.5 raised to the power of x, and I'm going to put that on my table. And you can see if I go -1, -1 is 1.2. So 1.2. So that's pretty close. 2 looks like it's going to be somewhere, maybe a little bit more than a half, just barely more than half. So somewhere around a half anyway. So let's go on up to that, and we get 0.48, which is very close to half. So I want to say that this is pretty much right on what it needs to be. If you want to put some more in there, it looks like that 0.5 is going to be up 5 maybe. So we could put in a 0.5, and it's hard to put in a 0.5 on this calculator. So Then we got to go table set, and let's go up by 0.5. And if I do that, then you can see I'm going up halves every time. So if I go up half, you can see 0.5 is 4.7. So yeah, that could be a half, and 4.7 right there. So it's kind of hard to tell on this table if it does hit lattice points, but again, it's got to be an answer choice too. So if it's not one of your answer choices, then you know that you missed it. So an answer choice should get you the exact answer on it. Okay, let's go on. Okay, so let's look at this one. We've got the value of F-150 has increased exponentially over the years. Okay, what is y-intercept? Well, right here is the y-intercept, and guys, that looks like that is going to be about 1,000. There's 2,000, 3,000, 4,000, 5,000. So it looks like it's going to be about 1,500 is the y-intercept. What does that mean? So if this were my truck, and it would be the year that I bought the truck. Okay, so let's just say that I paid $1,500 for this truck. What is the x-intercept in this problem? Well, there is no x-intercept in this problem. Okay, there is no x-intercept in this problem is what you'd have to tell me. In the context of this problem, what does the y-intercept represent? Okay, again, that is the price that when it became an antique, how much it was worth the day it became an antique, or you could say that was the price the day that I bought it. So it could be either one of those. Okay, the domain of this. So the domain, look, this is a word problem. The domain is not going to go negative. We're not going to go backwards in time, because if it became an antique right here, then a year ago, okay, it'll just say this is right now. Something became an antique today. It became an antique. Well, yesterday it wasn't an antique, and a year ago it wasn't an antique. So we're talking about an antique car that's going up. It was not an antique a year ago, so we cannot go negative on this. So the domain is going to be x is greater than or equal to 0. And what is the range? Well, what's the smallest number on the graph? Okay, so when I look at this, the smallest number right here is 1,500. So y is going to be greater than or equal to 1,500, and that is going to be the range. Okay, and I've already said why can't the x value be a -1, because if we're assuming that this is the day it became an antique, then a year ago it was not an antique, so we can't do that. Now that's just on certain cars and stuff. Okay, got a few more. Okay, suppose an ATV costs $8,000 and loses 15% of its value every year. And you can see here it asks you to complete the table. So let's complete the table up here, and let's see if we can do this. So to do this, I can see that it's losing 15% of its value, which means it's retaining how much? How much does it retain? If it's losing 15, it is retaining 85% or 0.85. So to write an equation for this, I'm going to write an equation before I do this, before I fill this in. So the equation is going to be, well, this thing was initially worth $8,000, and it's losing 15%. So this is going to be 0.85, and this is going to be the power of t, which is going to be in years. So I can do this a couple of different ways. I can put it in this part of the calculator, and I can go 8,000 parentheses 0.85 close parentheses, and I want to go raised to the power of. I don't want to go raise the power of anything. I want to go like first. I want to go. I'm just going to do that. Okay, so let me just do that. So let me delete this. I'm just going to go that. I'm going to do it recursively. I'm going to get 6,800, and then I'm going to go times 0.85 again, and I'm going to get to 5,780, and then I just have to enter. This is a smart calculator. Okay, hit enter, and the next one's going to be 4,913, and the next one is going to be $4,176.05. So that's completing the table. And you can also take this thing up here, and you can keep doing that. But to figure out the year 12, you're going to have to keep up with it. So that's going to be year 5, 6, 7, 8, 9, 10, 11, 12. And I hope I did that right. And I want to say 1137.93. But I'm not going to trust myself on that, so I'm going to do this one. I'm going to put it on the table. So I'm going to come up here and put this thing on the table. So it's going to be 8,000 is the initial amount. The multiplier is 0.85, raised to the power of x. So when I look at my table here, you can see that I've got, okay, 8,000, and gosh, this table is not right, or did I hit something wrong? So, I'll see what I'm doing. Okay, let me go back to my table set, because I changed my table set a second ago. Second table set, and let's make this thing go up by 1 again. So if you mess with the table set, well, no, you mess with it. Okay, so $8,000, 6,800, 57.80, 49.13, and 41, and they're just going 10. So look, it's saying 10, but if you click on it there, then you can see that it's going to give you to the exact penny here. This is a rounded off number. So if you want to go to year 12, let's just scroll down to year 12, and year 12 is going to be 1137.93. Okay, which is what I did here. So I did count it correctly, but I'm not going to trust myself. I'm going to put it on the table, and I'm going to get the answer off of the table here. Okay, let's see if we got any more. Already done that one, and that is the end of this review, guys, okay? So let me end this right here, and y'all make sure y'all watch this, copy down every problem, work it out, show all your work, give me the answers, and that's your ticket to take this test. Y'all have a great day.